All right, so today I have Malte Pietsch of Deepset. He is the co-founder and CTO of Deepset, and more importantly for this episode, Deepset is the creator of one of my favorite open source projects, Haystack, which on the website is described as an open source LLM framework to build production-ready applications with an emphasis on production-ready applications, which is what attracted me to Deepset in the first place. So, first of all, what do you think about that description from your website? Does that?
Yeah, I think like it's in a short tagline at least covers it. So I mean, yeah, we are like an orchestration framework for LLMs, and yeah, as I said, like I think our focus and also where we come from was always pretty much like building robust applications with a, I would say, special emphasis on retrieval augmented generation and a lot of like high degree of customizing pipelines. And that comes basically from the early days where we started the project.
So it's interesting because you're not the first person on this podcast who's used the word orchestration. I had Alex, a semantic kernel, so they also use the word orchestration. So in my mind, the word orchestration comes with a few things. One is what so the traditional orchestration, right? So in the realm of Airflow, Dagster, Prefect, and whatnot. So what does orchestration provide you? Monitoring, execution, observability, automation. But on the execution side, you know, it helps you with retries, right? And things like that. So with these LLM frameworks, I believe they're still not quite in that full-fledged orchestration in the classic sense, right? So there's no monitoring and observability as best I can tell, and no help with retries, right? So
yes, mostly. Like I mean, you can build in some retry logics and kind of loops, but I would say it's the
but
emphasis.
It's not handled by the framework.
Yes, you have to like put it in basically manually. And I mean, like if we look at our like how we do orchestration, how we understand it as well, it also really includes the design of your pipeline, of your graph, how you put different models together, different tools or vector DBs, because that's basically what we realized very early. Like when we were in the early days of Deepset, we were bootstrapping and working with like a lot of enterprise customers, bringing custom NLP systems to production with them. That was like 4 or 5 years ago, and there was always then this question like, how do you where do you spend your time? Like on basic glue work, having, I don't know, components that you again and again need to connect, or can you focus more of your time on optimizing really for the use case? So in our understanding, orchestration framework also really means a framework where you can put different, let's say, Lego blocks easily together, you can connect them, and as with Lego blocks, they should have an easy standardized interface. You can stick them easily together, which allows you to build very complex things like with Lego, but also to swap out components. So if you're, for example, in a early stage, you just want to get started, want to build your first prototype, maybe you have like a different technology choice than when you go to production, and still I think a good framework allows you to then swap and not like rewrite the whole thing.
So, but if you look at the orchestration category that I alluded to, the Airflow, Dagster, Prefects, and whatnot, they do kind of that Lego block kind of thing. But obviously their target there is more data engineering pipelines, and there's even what is it, the that startup out of Uber that's doing microservice orchestration, right? So. But like I said, so it seems like the main offering there is, the ability to glue the different blocks, the observability and monitoring, automation, execution, right? So including retry, scheduling, and all of this, right?
Yes, and of course like customizability. So I think overall these frameworks, they should save you time, right? So
Yeah.
should make your life somehow simpler, because otherwise, I mean, you can.
What's the point?
Yeah, what's the point? You can write everything from scratch, right? So I think there's only a use of such a framework if it ultimately makes your life easier and saves you time. And I think the important point is not only in the first steps. Like it's, I would say, relatively easy to get started with, I don't know, 2 lines of code and like automagic, you have everything up and running. But I think a good framework should support you and make your life easier all along the way. Like when you move from a first prototype, maybe to advanced customization, and then later to production, it should kind of enable you in all these stages. And that's what I think one of our design philosophies in Haystack, why we have it made very customizable. So let's say you can start with a easy pipeline, have like basic components, let's say a standard rack pipeline, but then at some point you probably want to customize. You want to change a retriever in there, or maybe inject another node somewhere in between. Maybe you even want to write a custom node. And it shouldn't be then that you have to start from scratch again and think about it in a different way. It should be just like, oh yeah, this was my pipeline. Here I put something in. And that's, I think, what we believe in, important part, and where we also differ to other frameworks.
And I think the other phrase that's key to what you're saying there is the production ready, right? So as you alluded to, obviously, if I had only one LLM application where I kind of know exactly the components and I can write everything from scratch, right? So maybe using the API of each component. But the point is, as I scale to, let's say, I have more complex pipelines where it's a mixture of fine-tuned LLMs with a routing model, and I have 20 teams doing these kinds of things. So you want a tool that will allow you to build these things in kind of an efficient way where everyone can understand what each other is doing, but also comes with all of this kind of the ops kind of capabilities that these orchestration, at least in the classic sense, right? So this monitoring and all of these things. And I'm assuming that at some point you guys will increasingly add some of these capabilities for teams so that they can really focus on building nice, delightful applications and worry less about all the glue code and the ops.
Yes, exactly. Because I think right now, teams should really spend time on figuring out the use case and the true value that they can deliver, and not like, doing this glue work. And I think, you can write stuff from scratch, but as you said, like you will do this over and over again. And if you have multiple teams working on it, you start kind of reinventing the wheel. Then I think the whole ecosystem is still quite early, and the tech everywhere is evolving rapidly. So I don't know, new vector databases rising, new model providers rising up. VectorDB is having like breaking changes from one release to the other. So I would really question, like, is that they do want to take care of that? Are you fine with or making now a bet and saying, okay, this is like my stack. I don't know, place everything on OpenAI and I don't know, this one VectorDB. Or you do want to have like some flexibility and switch later to another component, or kind of offboard this, say, maintenance, migration work to some framework provider.
So we'll talk mainly about Haystack in this episode, but for our audience, can you make a distinction between Deepset, the product, and Haystack, the open source project? What is the delineation?
Yeah, absolutely. So Haystack is really a Python framework. mainly looking at single developers, building pipelines, and then doing, let's say, also work around it. So really figuring out how to like putting that in their own stack, running it there, and yeah, basically looking if that fits for their use case. With Deepset Cloud, we really target enterprise teams, so multiple developers, typically multiple projects that they work on across the whole company, and yeah, it's really an end-to-end platform from uploading your data set. The whole infra is managed by us. We have a lot of collaboration tooling, for example, to iterate quickly on your use case. You can very quickly spin up your first pipeline. This is like based on Haystack. But what then? Like then typically product work starts. So you want to share a prototype with end users, collect their feedback, iterate again. You want to run a lot of experiments to figure out, okay, what is really the best retriever, for example, in my pipeline? Where's really the bottleneck? All of that is basically part of Deepset Cloud. Our enterprise offering, everything that is, I would say, technology that is around this orchestration is open source and will always be open source with Haystack.
I don't know if you guys are aware, but there are teams deploying Haystack, the open source project, to production. So it's not single people.
No.
You know what I mean. So somehow they are able to do it without all of the goodness of Deepset Cloud.
Yes, of course you can do that, and we're happy that they can do it and support it. Like we're aware of many use cases at Netflix, for example, as well. So, but it depends, I think, a bit on the what are your key capabilities also in the company? What how fast can you spin up the infra around it? Do you want to manage this infra around it or not? And that's basically where the distinction happens.
So as far as Haystack, I don't know. So how do you how do you understand how the community is using the project? So in other words, do you just rely on whatever forums you use? I don't know what you guys use, Discord or Slack, or do you instrument Haystack in any way? So how do you measure usage?
Yeah. Obviously we have forums like Discord, which is a very active community where we also ask a lot around for trying out early features, for example. Then we do a lot of user interviews. I think just last 2 months, we probably did 20, 30 in-depth user interviews to figure out, okay, what is important for people? How do they actually run it in production? What's working well, what not? And using that also a bit to prioritize our upcoming 2.0 release. And then the last third part is actually data. So we have a telemetry that we used. You can always, of course, opt out. We also don't track any sensitive information, but we track something like what kind of nodes, for example, use which document store. How do you basically, which components are really used and which not, which gives us a lot of interesting insights on where we should double down on, what is important for the community, but also where maybe a lot of errors pop up, what needs improvement, and of course, overall usage, how many, large scale pipelines are running out there, how many are probably in production.
So as far as usage pattern, you mentioned that retrieval augmented generation is a very common usage pattern. So what percentage of people who use Haystack are doing RAG?
Probably 60 to 70%. And yeah, I think we still have we differentiate there a bit, let's say question answering, retrieval based question answering. We still also have quite a bunch of people using extractive question answering, which basically uses a transformer model to really find a specific span in a text. But those two together, I would say, are 60, 70%. Yeah.
And what's the other 40? What's the other 40%?
I mean, you cannot, we don't track in like crazy detail, right? So sometimes I would need to look at prompts, for example, to figure out what are people doing if they I don't just use a prompt node.
Because the value of Haystack, if you're only going to one LLM, it seems like you can just go directly to that LLM. There's no reason to use Haystack. So obviously RAG maybe okay. So there's a few more nodes there. So what other design patterns do the remaining 30 to 40%? What are the common design patterns of those people?
So I mean, also like classic semantic search, like just retrieval is I would say still something. Then it's not all about, let's say, interactive RAG. So like the typical chat over your data, you somewhere index your data, and then you have kind of a chat interface or search interface where you fire a query, you get back a response. But we also see, for example, using that for information extraction. So rather batch jobs where you say, okay, I have a bunch of documents or files, and I know that for, let's say, for an example from a bank, every time such a file comes in, such a report, we want to extract certain information. And then you can also like build a Haystack pipeline that goes over these files, extracts every time, I don't know, say 100 questions, like the answers for these 100 questions. You put it in some database and kick off another process. Or we have another case where this is then shown to financial analysts or like officers who check reports, and they already have like a dashboard where they can then just see, oh, like these were the answers, and now this is where I want to drill down a bit more and see actually the context where this happens. So it's, I would say, slightly different flavor of RAG. And then of course there's summarization, there is agents, which I think is still early days, but yeah, there are interesting use cases also around that.
So let's drill down a little bit on RAG. I just put out a newsletter today, actually, because I've been kind of following the work of some people in Anyscale. And full disclosure, I'm an advisor to Anyscale, where they're, I think, basically trying to come up with heuristics to help people build RAG in a principled manner. So if you look at the classic RAG, right? So let's take the first half, which is the data prep, right? So first I have to choose what documents or data I'm gonna use. Maybe I acquire more, right? So maybe I generate synthetic data. Maybe I have enough, right? So I don't know. And then next step, I do information extraction, as you mentioned. If it's a bunch of PDFs, which PDF extraction library from Python do I use? There's maybe 10 of them, right? So if it requires OCR, which OCR library should I use, right? And then chunking. I have to figure out how to chunk that data. Then I choose the embedding model, right? And then I choose where to land the embeddings, right? So what vector database or whatever it is that I'm going to use. So that's the data prep. And then the actual RAG is, okay, so here's a prompt. Obviously, I already chose the embedding because of my historical data. So embedding model is chosen, right? So, and then I go to the vector database or whatever it is that I'm using. Then I have to choose the information retrieval mechanism. Is it hybrid? Do I use BM25 plus what nearest neighbor algorithm should I use, right? And so on and so forth. So I guess my point is, if you sit down and kind of lay it out, in order to build RAG in a principled manner, you have to do experiments. And so this is what the Anyscale folks are doing, and they're coming up with some rough tips for what people are doing. But in my mind, actually, to do these experiments at scale, you actually need a distributed computing framework like Ray. Because, I mean, just the embedding alone, if you have a lot of documents, if you're going to play around with different embedding models, it's going to take time. So to what extent do you might see that people are actually doing this sort of experimentation, or are they just, or are people just trying the first thing that comes to mind? Because the thing with RAG, honestly, is if you try one thing, you will get value. But the question is, if you want to get the maximum value, you have to do this kind of principled approach, unfortunately. And this principled approach is computationally intensive, right? So
yes, and I think I put it very nicely. Like what you described is, I would say, even a rather basic RAG pipeline.
yeah,
You
this is very
even
basic,
more
right?
complex, having rankers
Yeah.
and using metadata in the extraction and so on. So I think the point is, yeah, there's a huge optionality, and there is a big risk if you are too opinionated in the, let's say, in your first prototype. You may get something up and running, but you really don't know.
By the way, just to interject for our listeners, and this is why, besides needing a distributed computing framework like Ray, it actually helps to have a framework like Haystack. So as you're doing these experiments, you're not killing yourself with rewriting all your glue code.
Yes, you just want to like iterate, right?
Yeah.
Right? You want to have different swap in different nodes, tune a few knobs, have kind of a like a matrix that you want to experiment over. And yeah, I think there's three things that are important. One is having this flexibility in your code base where your framework can switch. Then the second thing is you need some mechanism to evaluate. Like if you run an experiment, like what metric are you looking at?
And scale.
You
need to be able to scale, right?
The third is scale, yeah. So you really need like ability to switch, ability to measure properly and really diagnose which node is the bottleneck, where should you maybe run the next ones. And third, yeah, you need some scale to run that, or distributed framework to run that at scale. And yeah, we actually used Ray as well. We're like, I think, early users 2 years ago started, I think. I think back then it was a lot on training, like most people and teams we talked about. I think remember at Microsoft, we're using a lot for training. We used it back then for serving, which I think wasn't so much the focus of the team back then, at least. Now I think it's way, way more powerful. And we have support for it in Haystack. So basically any pipeline that you have, we can serialize this to a YAML, and this YAML can be then also like loaded as a Ray pipeline everywhere. And we can then basically also scale the nodes, like the replicas for each node in the pipeline, depending on the needs. Like if you have a very compute intense model, somewhere maybe a retrieval model, you want to have maybe more replicas than for, I don't know, a pure pre-processing node. So that's in there. And yeah, we also used it in our commercial product, Deepset Cloud for a long time. There are multiple options how you can do this now these days. Ray is a great one. We right now use Kubernetes and Keda for autoscaling a lot. But yeah, you need some of this infra to really, I think, optimize and have the ability to actually iterate fast. And yeah, that's, I think, there's then the question, like, what do you use, what do you build yourself, and where do you maybe rely on other frameworks or Anyscale, I think, also has like hosted models by now, which can be very helpful, or use something like Deepset Cloud.
And like I said, so with RAG, the first thing you try will probably surprise you in terms of the kinds of value you can get. So the question is, are you getting the maximum value? And for me, I came upon this accidentally. For a long time, I just tried the first thing, right? And then I realized at some point, I just happened to be doing something where I actually knew the underlying documents well. And I started realizing it seems to be not getting the most. I'm not getting the most out of this thing. And that's when I went into the rabbit hole of tweaking these knobs. And for our listeners at a high level, if you don't want to go through all this experimentation, which we highly recommend you do. So I think the Anyscale folks have kind of discovered, for one thing, for example, chunking is actually quite a powerful knob to turn, more so than the embedding model, surprisingly, right? And of course, at the end of the day, your underlying data is the key to everything, right? So you have to have the right data. And
maybe to add one thing there, I think also one knob that we found very often with customers is utilizing metadata.
Yeah,
so
exactly.
not using just the embedding of your chunk from the document, but often there's a lot of valuable text to a file, or also like just like dates can be very important for RAG systems. Yeah, so that's probably another knob.
And honestly, take that to the next level. If you look at the traditional enterprise, right? So the types of documents they have already have metadata. Let's say email, right? So or reports, right? But more importantly, and this is something that I think people should start exploring, is that there might be enough metadata in there to turn that metadata information into a knowledge graph, right? So emails, for example, you have the from, to, right? So date, subject line, and all of these things. And then once you have a knowledge graph, you can do a RAG, traditional RAG, but now you have this extra relationship information where maybe you can leverage the knowledge graph, right? So the traditional RAG gives me the following answers, but these are kind of the related nodes or whatever. And by the way, our mutual friend Emil of Neo4j, they're starting to go down this path, right? So actually, to Maite's point, start with metadata, but you might want to take it to the next level. Because honestly, it's not a big lift to take those documents and turn them into a knowledge graph. Assuming you have a lot of that information, right?
Yeah, I think we're at the interesting point where everyone is talking about RAG, and everyone's talking about vector search. But yeah, ultimately, I think it's all about providing meaningful information, meaningful context to the LLM. And that is, I think, it's not only vector search. And you can start pairing it with, we mentioned BM25 to have like basically hybrid search. There's like I don't know how many years of experience information
another knob there. Actually, I'm kind of I was joking with some people at Anyscale because they have this library Raytune, right? I said, what we need is to just kind of really if we have access to a cluster, just let it rip. Just let Raytune kind of turn all these knobs and come up with the right configuration, right? So, which, by the way, we should discuss for our listeners, Maite, this notion of evaluation, right? So if you're building a RAG system and you want to know if you're going down the right path in terms of this configuration settings that we're alluding to, you need an evaluation data set and some evaluation metrics. So what's the simplest things that people can do in these areas in terms of so evaluation data set? Describe what that might be and what would be a decent evaluation metric, just even the most basic.
Yeah. So I think the most basic thing, like two things you can do. One is, and that's what we recommend if you get started, get up your RAG pipeline, collect user feedback, like really just thumbs up, thumbs down kind of style. So in the live system, see what people are querying and how they rate basically the outcome, to get a very first understanding. Hey, like, is this useful, and what kind of queries are people actually asking? Then, of course, you want to become more systematic. If you want to run experiments, like multiple ones, if you want to rerun maybe at a later point, you need really starting to put together a data set that you can use for it, evaluation set, and you can sometimes you can use the previously collected feedback just as a kind of starting point. Queries, was it right, was it wrong? But then typically you also do at least a small labeling process where you have a few people kind of labeling, hey, is that the right document? Yes or no? Is that the right document? Right answer. And the good thing, I think, by now you don't need, it doesn't take as much time as in the past. Like when we did that, I don't know, 3 years ago, was like, I don't know, days of labeling. You also want to have something for fine tuning. So the data sets have to be much, much bigger. Right now, this can be really a few hundreds of examples, maybe. And this is something you can collect in a few hours. And yeah, once you have your evaluation set, and I think right now for RAG, it's most important to actually look on the documents, on the retrievers. You really need on this level, did the retriever get the right documents, yes or no? And yeah, once you have that data set, you can use different libraries. You can use Haystack, of course, but there are also many others to evaluate the performance and get metrics for those retrievers or other nodes in your pipeline. There are different metrics you can look at. Mean average precision is one of the, I think, quite common ones. And it's all about how are the results ranked, not only looking at the first one, but getting a mix of where is the result coming up. And this depends a bit on your use case, what you want. Sometimes it's more important that you really have like a high, like really high recall, you have all the documents in there. Sometimes it's more important to have a diverse set, for example. But yeah, that's, I would say, where I would start. First user feedback, then a proper eval set, and then running those experiments, getting metrics, and the important part, metrics on a node level, not only on the, say, last outcome of the LLM, but also trying to understand what is performance of previous nodes, especially if you have retrievers or rankers.
So, all this this discussion reminds me, Malte, of basically classic ML and ML ops, right? So in many ways, we're describing building RAG in a principled way as, you're doing some kind of hyperparameter tuning on different knobs to come up with a RAG system. And then you have an evaluation data set. Then obviously you deploy to production, and then you start getting user feedback. You constantly improve. It's so a lot of the kind of the muscles you have for ML are there, but it's just a completely different beast and setting, right?
Yes, and I think the speed has like accelerated a lot. Like in the past, you had also like this training stages and like very lengthy, say, projects to really get a decent performance. Now I think you can get this decent performance way, way faster. You don't need to run too many experiments and tune too many hyperparameters. It's helpful, but I think you don't need that much time to figure that out. So it's, I would say, one difference. The other is, I would say, still on metrics. So we talked about now evaluating retrievers and maybe some other parts of the pipeline. For the generated,
I think retrieval and the quality of the answer, right? So you got retrieval score, but then the LLM will present the answer, so the user will have to evaluate the quality of that as well, right? So
yes, and this, I think, is still where, like in the past, from, I would say, most NLP tasks, we had quite reliable metrics that we optimized and used to, okay, yeah, if we optimize this, it's somehow the right thing. I think now with the generated answers, particularly, we don't have such a metric yet, like not a reliable one. We have some heuristics, but it's the longer the answers get, and it really depends on your use case, what you want. Like, does it have to be factual correct? What about hallucinations? What about like the style, the tone of these answers? So there can be different, say, metrics or goals that you actually want to optimize. And and we don't have, I would say, a standard set of metrics to do that really properly.
So you mentioned hallucination. So listeners might think, well, isn't the point of RAG to kind of either make hallucination go away or at least really reduce it? And secondarily, the other point of RAG is obviously you have domain-specific knowledge. You have you can control the diversity of your data, and then finally latency, right? So kind of the classic RAG benefits: hallucination, data quality and diversity, and then latency.
Yeah. That's definitely like three good reasons for RAG. Still, if you're going to production, if you're have an enterprise use case, maybe a customer-facing use case, it's not good enough if you say, oh yeah, like hallucination with RAG is better than with pure LLM. So there are still cases where models hallucinate even in RAG, like happens all the time. So it's still important to figure out when this happens and start measuring it. And there are now like first approaches to do that. There's interesting work from Cohere right now who've like some grounding, I think also in their offering, their product. We did some work on hallucination detection as well. I think the core idea there is, well, there are two streams. One is it's all model based, so you basically generate your answer, and then afterwards you have another model, another step that checks if there are hallucinations. What we do, for example, is looking or using the documents that we got from the retriever in our RAG system, and hold that basically to the side of the generated answer, and let the model on a sentence base figure out, is that sentence here generated in the answer somewhere based on the documents? Is it grounded? Yes or no? And you get basically on a score on a sentence level, and that gives the user some guidance. You can put it in your UI and flag maybe, oh, like there's something missing. Or of course you can use it in kind of observability manner on an aggregated metric. Say, okay, what's our hallucination score? How many answers were above a certain threshold? That's something you can do. The other approach is basically looking into some external data sets afterwards, doing web search to figure out if these facts are grounded or not, the answers are grounded or not. But it's still, I think, early days, and I'm sure we can all improve there as a community.
So assuming that the retrieval stage of RAG actually returns candidates, what is the taxonomy of reasons why hallucination happens if there's viable documents that are returned in the retrieval stage?
So sometimes, I mean, first it's like, are there really viable documents?
Yeah. So let's assume, yeah.
Let's assume. Okay, let's assume. Then it can still happen, like also depending on your prompt, how close the model should be to like what you have in there. And I think about this as a bit of a spectrum, depending on the use case. For some use case, you want to be really, really factual. So you rather let the model say, I don't know, I don't have this data available, instead of like hallucinating or making something up. And you can tune that via the prompt. But then there are also use cases where you say, but like it should be grounded, but maybe I don't have all this information exactly like this in the documents, and then looking into the basically using the internal parameters of the model can be also helpful. So you want maybe also some creativity or
temperature.
The temperature maybe is also a way to do that. But there it's not. I think there's a spectrum of what you want in a use case, and then even if you go, I just want to be very close to the documents, hallucinations happen because the model mixes stuff up. It's still possible.
So tell me if I'm unnecessarily worried about this problem. Tell me if this is a non-problem. All right. So one of the things that I think gets underestimated in this RAG architecture is information extraction. Right. So I alluded to, let's say you have a bunch of PDFs. You have a PDF extraction library from Python, but how do I know that that thing is extracting everything out of my PDF? What if there's interesting data embedded in captions to images? Or I don't know, I'm just making it up, right? So same thing with web pages, right? So there's many different web crawlers. So how do I know that whatever web crawler I'm using is getting the most out of? I mean, if you look at a typical web page, it could be a mess. There could be ads right and left, right? So how do I know it's getting to the heart of what I want, right? So am I unnecessarily worried about this? Is this a non-issue or?
No, I would say it's an issue. And I think like especially take PDFs, like it's a horrible format to work.
Oh my God.
it's so messy, and you have like so many different edge cases that you want to take care of. And if you have like, if you're an enterprise and you have like big data sets, like a lot of PDFs, you also have usually a lot of variety. And this, I think, is where also like this, there's a difference between doing a prototype on 2 or 3 PDFs that you know well, where you know, okay, this is the structure, or like on hundreds of thousands or millions. And I think, yeah, for example, PDF conversion, there are still many, there are a lot of different libraries out there, but I think
what about web pages? Am I unnecessarily worried about web pages?
I think like it depends what you want to get out of it, right? So I think basic texts.
You know, you
right?
pointed to a web page. Some of these web pages, here's the URL, here's the thing I want, but there's like an article at the bottom, you know.
Yeah. And this is, I mean, this is, I think it's like it's a bit the question, like where's our like quality expectation to these things, right? And I think so far they were, I would say, rather low. But if there's so much potential, not only getting, let's say, the text out of a PDF or web page, but then also this whole metadata around it. What is take a PDF, what are captions? What is the a table of content, like navigations? Like what is then maybe a graph or navigation tree? Same for websites. Where is it?
Is there information buried in an image? Right. So
yes.
if there's a chart, maybe there's nice information in the chart, right?
But what we get even more is tables. Like, I mean, we work a lot with financial institutions, and there, most PDFs. If you take, I don't know, an annual report or an ESG report, there's a lot of interesting information in the text, but then also tables. And if you ask questions, you want to make sure that you get both of these data sources. But then, it becomes even more messy to extract that. But on the bright side, we also have, I think, more powerful methods right now. There's, we can use also models way better now to pass this kind of information. And I think maybe to look a bit in the future, I think this will be super interesting and maybe 1 year from now, 2 years from now, that you not only access pure text information, but that you have a variety of information sources. And this can be websites. This can be also, I think, other databases. Could be a graph database. Could be also a Postgres database where you generate maybe some SQL queries. So I think when we think then back about LLM applications and maybe even RAG pipelines, I think we won't have a single retrieval step with a single vector similarity search. But you will have, first of all, multiple data sources that you can use, and maybe the model picks like a bit like an agent which one to query. But it will be also iterative, I'm sure. Like you try this data source, you see what you get. If that's not really what you need, you go to another one. And finding there, I think, robust mechanisms, fast mechanisms that you can really iterate and get the relevant context. That's, I think, what I'm most excited about for next year.
And again, this is why a framework like Haystack is ultimately very useful, because you can focus on doing all these experiments rather than writing all of this glue code in order to run your experiments. And by the way, RAG, Retrieval Augmented, just those 2 words indicates that it really comes down to your data, the quality of your data. If you know, the whole point of augmenting the language model is you actually have something to augment it with that's good quality, right?
Yes, absolutely. And I think data quality matters, and then understanding what is really relevant. That's also very specific then to use cases. So I think this is where people should then spend time out, figure out, okay, what kind of data I want to put in there, what do I need to improve on the data quality side or the retrieval side to determine what's relevant. But not this glue work.
And that's why I think I'm glad you kind of reassured me that my paranoia about this information extraction ultimately being kind of like the foundation of this, right? Because I may have the right documents, but if I'm not getting the most out of them, I may still have an inferior RAG system, right?
Yes, it's definitely, I think, one of the big knobs to tune. I mean, there's so like stuff happening in the market. We are looking for like different integrations in with the ecosystem. Like Unstructured is, I think, doing some great work in providing many data connectors to like to also like let's not only talk about PDFs, but also the systems where maybe text data lives. So yeah, I think it's
Yeah, it
interesting.
just it's interesting to me because if you look 5-6 years ago in the data engineering space, pipelines, right? You had the rise of startups like DBT, Fivetran, Matillion, and all of these things focus on data pipelines just for structured data going into lake houses and warehouses. We need the equivalent set of tools for this world of unstructured and semi-structured data, even doing that magical step of taking a semi-structured collection of documents and turning it into a knowledge graph and things like that. So tying this to the data engineering space, as you know, one of the big things there is streaming in real time. So at what point do we get to RAG systems that are, incrementally updatable, index gets refreshed in real time? I think actually that's starting to happen. There's a startup out here, Rockset, built by the people, started by the people who built RocksDB. So they're inherently real-time people. So they're doing kind of a vector search, but they're since they're real-time people, they're real-time by default. But how soon before the rest of the world becomes real-time by default? Prediction.
So I think I would guess it takes a little bit longer. Where I see the market right now, it's I think like we're still in the indexing stage where people put in their initial data set and then they're actually happy if they can keep it up to date, like sync it maybe on say with minutes of delay. And I think this has already improved quite a lot in the last year. If I think about our use case and customers, we can easily now index millions of files in a few minutes initially, and then if you sync it, it's usually a few seconds or minutes. But it's not streaming, right? It's not and not like on the scale, like having Kafka streams and then directly reading or having the LLM application sitting on top of that. I mean, I'm curious. Like, I was curious about the use cases where you really need this direct streaming.
Well,
yeah,
I mean,
imagine
search, right? So look at Google, what is it, 15, 20 years ago, kind of rebuilt their indexing system so that they can index the entire internet within minutes, right? So you can imagine something powerful like that in the RAG space where you just are confident that you're always getting the most up-to-date information.
Yeah, okay. But depends like on I would say on.
I mean, it's not a must-have. It's not a must-have right now because we're just in the basics, like you said. But I think at some point it'll be kind of a must-have because people will get used to once they touch a system that's more, real time or near real time. They might, okay, that's what I want moving forward, right? So.
Yes, I think like, but if you have like if you think about the data sets right now that are out, like if a company, how often do you, update a document? You can send an event saying, oh yeah, this is updated and get it indexed. I think that kind of works. What I thought more about was, I don't know, if you have like click data of streams, if you're in a kind of big data space where
like you said, you already mentioned this notion of like Postgres now has vector search, right? So, but as you mentioned, since you're already using Postgres, you might as well kind of infuse your RAG system with kind of SQL-like results. So you can imagine why not, right? So if you're interacting with this Postgres system, both in the vector search and kind of analytics point of view, so you might as well get real-time results, right? So
yeah, and I think that's a good keyword. I think analytics. So if we think about analytics or BI, they can definitely also see use cases where that would be very interesting. Where you have, I don't know, if like one customer, they have a BI team. They want to kind of automate certain requests from the board, from the management. Like what kind of and how many customers do we have in region A? How did a certain product perform in the last hour? So where you sometimes really want to have up-to-date data. And I mean, there, of course, I can see if you have like a RAG system or an application that has access, that sits on top of these data streams or of this like real-time data, querying it and getting results from it. Yeah, this could be interesting.
So I don't want to put you in an awkward situation, so feel free to pass on this question. But so I've had numerous conversations, both in this podcast and offline, about this category of vector databases. And I think kind of the general conclusion of most people is that it's not a standalone system, right? So in the sense that there are now systems that are adding this vector search capability. We've mentioned Postgres, Mongo has it, Elastic has it now, Cassandra, Neo4j, right? So the rock set people have added it, and so on and so forth. So yeah, so to the extent that you need vector search, will your existing systems that are adding vector search be capable enough? Probably, because the alternative, Maite, is to get a separate system and then work with another vendor, right? So I think that the vector database category right now needs to do more than just vector search in order to be a viable category moving forward. Agree or disagree?
I think definitely they need to do more than just vector search, and they're doing, I would say. They, I don't know, start adding, or they have added metadata filtering.
But the other systems will add that too. Yeah.
Yeah, I mean, it's a basic question of like, why don't we have a single database today? Like, what's the point where a separate system makes sense? Why, I don't know, is Elastic?
But yeah, so I think the answer is you have to do more than nearest neighbors, right? So vector search, right? So
Yes, absolutely.
If that's all you do, yeah.
And then I think it's a question of what, like to what degree do you need vector search? To what scale? To what, I don't know, is that the key of your use case? I mean, look at like search. You can do very basic, very basic search in Postgres, like string matching. For some use cases might be enough. For others, people started to turn then to Elastic because they wanted like much more.
The category name is actually quite loaded, right? So vector database. So there's the word vector, but there's also database, and database connotes a lot of enterprisey, rock solid features that, you know, the existing vendors have, and it's much easier for them to add vector search than vice versa for the vector search people to add all of these database features that enterprises want, right?
Yeah, might be. I'm like, I mean, if I have to make a prediction, I would say we won't see that many vector DB providers in 3 years from now anymore.
Yeah.
It's, I think, definitely like a lot of providers out there. But I would also expect that not all go away. I think there will be a few surviving, and for a reason. If I look today at our, I mean, we talked about insights and community and what our Haystack users are using. We still see like a large fraction using Elasticsearch and OpenSearch, which I would say is also one of the examples where we're maybe a bit slower in adding vector search, but they did it, and it's especially in enterprise context sometimes easier to run those systems because they're already in place. You don't have to procure anything. You don't need another, say, ops team to take care of it. So there's also, I think, reasons why, or like cases where people rather stay with those. Well, I think with others, if people start from scratch, if they're very specific on what they want, vector search is the main thing for them, then I would also see cases still for vector DBs.
Yeah. All right, so let's close with Haystack 2.0. So what are some of the key things that are, and by the way, for our listeners, we're talking about Haystack 2.0 in mid-October. This podcast comes out mid-November, but Haystack 2.0 doesn't come out until December or January. So just for some context. So Haystack 2.0, give us kind of some of the highlights.
Yeah, sure. So yeah, we are kind of developing it in the open. So all what I'm saying now, you can also follow on GitHub and Discord. But yeah, the main thing that we realized over the last years is that you need a solid foundation in an orchestration framework, and it's really the basis for everything that you build on top. And what we had in the past, what made sense was having a direct acyclic graph for pipelines, so really clear execution, step by step, no cycles, no loops. But in I would say the era of LLMs, there are now a lot of other interesting use cases where actually want to have loops and more flexibility in putting together your pipeline. So with Haystack 2.0, we are completely redesigning pipelines and nodes. So the basic of the framework. You will have much more options to customize it. You can, as I said, like put in loops. You can have branching, like parallel branches, which are especially important if you want to have like some fallback options, for example.
What the orchestration tools and the other type of orchestration tools have done, right?
Yes, it's like, I think it's to some degree like a logical next step. And I think we don't need in many cases, for example, separate concepts like agents if we can have a loop in a pipeline. If you can just, I don't know, iterate with your retriever and autocorrect, a loop is enough. We don't need like a new concept, a new agent, for example. So that's definitely one thing. The other thing is around basically customizability. We want to make it way easier to create custom nodes, because it's nice if you have a lot of predefined components, but there's always in a real use case then something you need custom, where, I don't know, you want to connect to a certain data source, for example, or build maybe another retriever mechanism or so. So this will be all way more flexible, way more customizable. And the other two themes that we see for 2.0 besides customizability are ease of use and robustness. So for the ease of use, it will be like we have simpler paths for, let's say, getting started, because I think in a good framework you need both. You need this customizability, but also an easy entry path. And then, of course, in connection between two. You start easy, you get your, I don't know, first RUG system with a few lines of code, but then also, how do you get to the deeper level, advanced level? This is something we want to improve. And then on the robustness side, which I think is it's very important for going to production, we will have some stuff on the monitoring side, tracing side. So there will be an integration with OpenLLmetry. We're also talking to base run, so a bit like tracing the execution of your pipeline, what calls are actually done. And we also will have async execution in there, so they can properly scale. OpenAI is I think has some special latency on some days. So you want to make sure that you can still run efficiently and have really async execution.
Yeah,
so that would be
yesterday I was using OpenAI. Now, actually, I mainly use the Anyscale endpoints, but every now and then I use OpenAI just to generate data. And I was using it yesterday. I had to, for the first time, I had to put in some retry logic. I was getting rate limited. All right. So actually, one last question. Give me a sense of the Haystack community. Are most of the contributors inside Deepset? Or so what's the makeup of the community, the core community?
Yeah, so I would say it's really a big mix right now, or it has been, I think, also over the last year. We have big tech using it, contributing it, from Netflix, Intel is a big user, NVIDIA. That's one category. The other, enterprise, so classic enterprise, a lot of banks, pharma, but also media is big. And then last category, startups, of course. Yeah, we have users and contributors from all of those three, and also like more contributions, I would say, or like a lot of contributions from community. It's not by this point in time, it's not just driven by Deepset.
And with that, thank you, Malte.
Thank you. Thanks for having me.